you did the vertical and the horizontal distribution, right? Did you guys do that? You did the torsion, all that good stuff?
Yeah.
You calculate the torsional, so I'm gonna see that next week. But let's say you did all the numbers, you did all the analysis and the numbers are correct. And this is one of the shear wall. So, and these are the loads going to particular shear wall. At each, again, floor, you can have a shear and a moment. Shear and a moment. And that moment will be that force times that height, right? That shear will equal that one. Here, this shear will equal these two forces, right? Plus this force times that moment, this force times this arm. The shear here, again, will be 1, 2, 3, right? The summation of these forces, correct?
Yes.
Yes, and then that moment will be that force times that distance, this force times that distance. And so do the shear and moment for each cross section. Then there is a program called BC Column. Have you guys heard about that program? You can download a student version for that BC Column. No, I think it's BCA. And then you lay out again, we're gonna split it every 2 floor, the geometry, the thickness, and the length, and you lay out the reinforcement of this shear wall with the one that's in the boundary condition. Here, usually in the shear wall, we have an element we call boundary condition. It's basically a column that's embedded within that wall. Okay, and you model this in the BCA column for axial, because you're having axial load here, right? And moment, right? And then you go back and use the shear values to design. So the horizontal part are checked using shear forces. The vertical bars are checked using axial and moment, and you're gonna have to use a program for that. Use BC Column program. You have the length and the plans, and I think you also have the thickness. So the geometry is already given to you. What you really need to determine is the reinforcement of that wall. Okay? But in order to get there, you need to draw that 3-bit diagram for every single wall.
Is that basically the Portal method you're explaining there?
Yeah, that's the proto method, kind of. Yeah, it's an approximate method. But for a shear wall, not for a frame. We're not doing a frame yet. For a frame, you put that loads, and then you assume the hinge in here,
Yeah.
and then you do that. But we're not gonna do that. Okay? Since we decide we're just gonna use the shear wall, we're not gonna combine with the frame, right?
Yeah.
Okay? So can you work on this till next week?
Next week is Thanksgiving.
The week after?
That's the week before finals.
Correct, and we'll stop there. And I'll try, even though I'm not gonna be here next semester, I'll try every 2 weeks to check on you guys with Lisa. I'm not gonna leave you alone. I'm gonna, every 2 weeks or 3 weeks, I'll try to visit, just checking your progress and work with you on the model. But let's try to get at least this by the week after, and that way we're meeting the schedule in terms of coming up with approximate cross sections for the columns. We don't have beams, right, except in the garage, but for the columns and for the shear walls. And what we're missing is a slab. And I'm gonna give you another book that has